We have already covered the lowest harvest rate of 2.0 times to the 10 to the 5 tons per year, and we saw that we have a problem with overfishing if we are below this equilibrium point. If we are above that equilibrium point, the amount of fish will not decrease to zero. So for the lower value, it depends. Namely, it depends on the initial amount of fish. The upper harvest rate clearly amounts to overfishing, independent of the initial amount of fish. The loss is always larger than the gain. So in this case, we surely have the situation that the amount of fish decreases to zero. If we use this harvest rate that just touches the peak of our gain curve, things get a little tricky. If we start with an amount of fish that's below 1 million tons, we lose more than we gain per time, which means that the amount of fish is going to become zero eventually. If we are in the region above 1 million tons, also the loss is larger than the gain. So we are moving toward lower amounts, but in principle we would be stopping at this equilibrium point where the loss equals the gain. This is what would be called a semi-stable equilibrium. On the one side it's unstable, on the other side it's stable. But imagine what happens if you have eventually reached this equilibrium from the upper side. Just a tiny disturbance will suffice to make you drop down to the left end of that curve. So almost surely the amount of fish will decrease to zero if we pick the rate of 2.5 times 10 to the 5 tons per year. This rate is called the maximum sustainable yield. In theory, you could be harvesting at this rate forever and ever. But of course, that's pretty dangerous whenever there's the slightest disturbance.